So here we're looking at integration of trig products. So here's a snippet out of our formula sheet. When we're integrating, we're looking at things that resemble the right-hand side on this sheet, so we can integrate it to get the left-hand side. So we're looking at these ones here. And we might have to, if they're not looking like that, we might actually have to change things around a little bit. And how we do that is that we look at other trig rules and identities to rearrange the function. The two most common ones, I guess, that we'll be looking at are the double angle formula and the products formula. So this is directly from the formula sheet. These are rules that you're given. So we're going to be using those. So let's have a look at some. So I've put the snippet out of the formula sheet. So we want to get things looking like this right-hand side. So the first example is 3 tan squared x. And as you can see on the right-hand side of the table, there's no tan squared x. So we need to look and see if we can rearrange it. And what we find on the table, there's a formula that says tan squared theta plus 1 equals sec squared theta. And if you notice, sec squared x or sec squared theta is on that table. So that's what we want to get. So we're going to rearrange this. And we end up with tan squared x being 1 minus sec squared x. So if we expand this out, leave the 3 at the front there, and we're going to expand it out. So that becomes 3 minus 3 sec squared x. And if we integrate that now, because we're starting on the right-hand side, you notice that sec squared x, to integrate it, becomes tan x. And so 3 becomes 3x, sec squared x becomes tan x with a 3 in front of it, plus c. And here's another example. So we've got 4 sine 3x cos x, and if you notice there's a rule on the formula sheet that says 2 sine a cos b equals sine of a plus b plus the sine of a minus b. So this is a 4 though, so what we're going to do is make it 2 times 2. And you can actually pull that 2 right out the front because it's just a coefficient, it just stays there anyway. So now we've changed it, so we've got 3x plus x equals 4x, 3x minus x equals the 2x. And if we integrate that, we end up with this. The 4 down the bottom becomes from this 4 here, just like the 2 there. Sine becomes negative cos, and so sine of 4x becomes negative cos 4x over 4. Sine of 2x becomes negative cos 2x over 2 plus c. So if you can't see that it looks like the right-hand side, you might need to do some manipulation, and that's by looking at your trig rules, products and sums, etc.